Hey everybody, we are live. Let me turn off the stream here so I don't hear myself twice. There we go. Got it off just in time. So we are going to go start with some 320 right here. Let's hop right to it. Let's do it. 320 coming up here on these 20 Point Tuesdays. Nah, class is not over. And my doorbell might ring. I've got, they're currently doing some phone service stuff for us. So if you see me be like, hey, I got to be right back, it's going to be because they had to take something. I also noticed that question number 4 problems are different than what is in the homework packet. Yes, that is correct. Hey, good to see you here, Adam. That is correct, Leia. Make sure to do these right here. So do these problems right here. So this question right here, can I take a screenshot? Hey, my 474 only because on line 11 in the code that was already put there, let me copy the error. So wait, it won't knit because on line 11 in the code that was already put there, let me copy the error. Yeah, definitely let me see. You might have to message me on Discord. So good question right there, Ellie. Hey, what's up, Amber? So good to see everybody's here. Love it. Can I take a screenshot of this? I hate it when I love it. I hate it. You know what I can do? Here's what I can do. I think it should knit like that, right? Okay, let's see what it does. Okay, let's get it. Yes. If you had to pick between 310 and 340, what would you recommend? If you are going to do a job like Eastman Chemical, which I'm not saying just Eastman Chemical, if you are doing a job where you have to do statistical process control, 340 is essential. 310 is about optimization, which I think is excellent. I think both classes are great. If you're looking for electives, and truthfully, the more analytical skills you have, the better. The problem is I've only taken 340. I actually took 340 with Charlie Quick, but I know Dr. Galbraith his reviews are through the roof. Both are Charlie Quick's reviews too. But Dr. Galbraith, not only a great department head, but an amazing teacher. And that class is very kind of project driven from what I understand, very working through, I think you work in groups some too. And I think it has a very good workload, as in very structured. So is Charlie's classes. Both those classes are perfectly designed, and I think you can't go wrong. My only experience is knowing the content of 340 very well because I took it and I've taught it. So I've taken and taught 340. If you're looking for more of a production type job, like some sort of plant, like with Pepsi or something like that, then statistical process control would be essential. I wish I understood 310 better. Charlie Quick also is our undergraduate director of statistics or of business analytics. We're the business analytics and statistics department. But Charlie Quick can give excellent advice on what courses to take. He knows every course in and out. I mean, I know 310 is the design and optimization course. I'm just not the best on every course I don't teach. I'm like, I know what that course does. I know some students who have taken it. Kenny's taken it. Kenny Miller's taken it. I think a few other people have taken it. But they're both top tier courses, Adam. They're both top tier. You can't go wrong. If you can take them both, take them both. So, but yeah, you can't go wrong. So our goal right here is to just solve for what when we do transformations. Our goal is to solve for what when we do transformations. Our goal is to do what when we solve for transformations. To solve for what? When we solve a transformation right here, what do we solve for? What do we solve for? What do we solve for? The chat in 201 broke yesterday, and I'm all afraid now because I'm like, is it broken again? Did the chat stop? No one's talking to me. I'm frozen. Our goal when we do a transformation is to solve for what? What is the goal in a transformation? What is the goal in a transformation? What are we solving for? What are we solving for when we solve in a transformation? Why, right, Timothy, right there. Timothy's working out, working his brain, working his muscles, getting strong, mind and body right there. Excellent job. 100 points, Leia and Timothy right there. So we're going to solve for why. So the whole goal is to just isolate this y component of the equation so that someone could put in an x and get a y out of it. That's untransforming the model. So we need to figure out some way to remove this log10 component of it. So we want to get rid of this log10 component and just have y. Well, the good news is there's a quick and easy way to do this, and it's 10 raised to the equation, but we have to also do it to this side. It's because it's log base 10. If it's log base e, then we'd do e raised to. So since it's log base 10, we raise both sides to 10. That's going to have this cancel and this cancel, And now basically we get just y raised to the equation. So y equals 10 raised to, and then this is 10 right here, plus 3x to the third. And I'm perfectly fine if you leave it like this. I'll let you write it out, but this is acceptable in my book, because it's just is what it is. If you think the graders grade it weird, please tell me. We have 3 graders, so sometimes grading can get a little bit interesting, but this is solving for y right here. From here, it's just algebra to reduce, but you can still just plug in the value of x, which is the goal of it. The goal is not to practice algebra, but use algebra enough that we get something where we're solving for y. So you can raise both sides. You can do 10 raised to both sides, and the equation stays the same mathematically. But then the point of it is that you have now removed out the component on the left-hand side. So, or you've moved out the log 10, which is the goal. You don't want the log 10 there. So does that make sense right here? How to kind of remove log 10? It's a bit of a weird one to get rid of, but what connects and cancels on this is that portion. When those two connect, they cancel out, because you can check this if you want to. Awesome, Leia. Great job. Thank you, Leia. Great questions right there. So if you were to say something like, here, think about this. What is this going to solve to? See, this would be a fair question on the test. What does this solve to right here? Wait, I made a mistake. What does this solve to right here? I didn't put a question like this on the test, but this is a decent algebra question to put on the test. What does this solve to? Solve this equation. What does it solve to? Solve this equation. Solve any of these equations. What does the first one solve to? Well, the key here is to realize that all we're talking about is this. Because what will it solve to? Because 10 raised to log 10 cancels. Great job, Leia. That's it. We solve this. Solves to 1. Solve this. Solves 50. Solves this. Does that make sense right there? So that's what's happening, is that when you connect the 10 raised to log 10, they cancel. So you just get the 1, you get the 50, you get the 1,000. So this is kind of just showing, great job, Kiana, great job, Timothy, great job, Adam, 100 points, all of you. It's just showing how this works, and then we can solve it. That's why we don't worry about solving it any further, because the program's going to solve it for us. But we just want to write this out so we can get it in units of just the y. So now when we solve this equation right here, it's in units of y. It's just whatever we get output wise here is y. Can you go over a step? Yeah, of course, Charlie, ask away. And if the doorbell rings, I'm going to go give the guy back his thing. Feel free to ask. You know, we work all problems right here. Was there a 341 also? Let me look, or 474, I think. Let me double check. We'll look. I think we're on to a new question time. New question. Ugh. When I can drink coffee again, it'll be amazing. I've got off Starbucks and then I got off coffee. It is a sad day. No Starbucks, no coffee. I need Starbucks. I don't want Starbucks. I need Starbucks. When you need something, that's a responsibility that only adults, my maturity. Coffee is key. Coffee is the key to everything. Yep, GGS and Laura here. Can you go over part 2 of chapter 13? Oh yeah, GG, of course. Yeah, and insurance company. So we'll do this one right here. Sorry, Amber. And then I think we did. There we go. Oh, do you mind going over? Yeah, we did 4B. Yeah, and then we answered that. So I think we did. And then Ellie's gonna email me about the knitting thing, I think. No, I'm not drinking coffee purposely. So definitely don't buy me a coffee gift card, because I won't be able to use it. Now, my fiance would love it. My fiance Chelsea would be very happy for that. I should accept coffee and candy. I love some candy. So I like candy, bubblegum and taffy. Skip to the store with my sweetheart Sandy. I like candy. Message you on Discord, but an email is. You can send me the file on Discord too. Send me the file over there. We're gonna do the insurance company one. I'll make sure that we will do it right here. There it is. An insurance company. Here we go. Okay, with the insurance company. Thank you, everybody. Great work, everybody. Good office hours today. Love seeing everyone here. So an insurance company checks for police records on 554 accidents selected at random, and notice that teenagers were at the wheel of 84 of them. So let's immediately identify notation right here. What do we have notation-wise? Right here? Oh, I'll take this portion right here. So what do we have notation-wise? Immediately start identifying notation in this problem. Immediately start identifying notation. Anyone know any notation here? Anybody? 100 points for a notation. 100 points for a notation. Any sort of notation in this problem that can be seen. This is the key to these problems. If you can identify the notation, you can usually solve it. I think you have p hat. You're right. So this is going to be n. And then an often forgotten one is that this is x. And then x over n equals p hat. Like my fat pencil right here. My gosh. Insanity. Fix the pencil, Brian. Okay, I'll do it. Calm down, everybody. There we go. Okay. Now we can solve for x over n, which is equal to 84. I talk to myself sometimes. Who doesn't? So this is going to be p hat right here. P hat is going to be 84 divided by 554. Please tell me if I make an error. That's 15.16, which thank you so much, Charlie. Excellent work. Charlie, an extra 100 points. Now what Charlie did instantaneously, now that he knows what p hat is, he's going to solve for q hat right here. And you can put the hats on these. It's just when we type them out in the sentences below, we don't put the hats because we can't type them in there. And so this is p hat, and this is q hat equals, you are possessed, pen. Really? I just don't understand. There's things I don't understand about this world. And so we have here q hat equals to 0.8484. Really? Really? I think it is. Gotta double check that. That looks weird. Yeah, 8484. And so there's p hat, there's q hat. And from here it becomes a solve the equation problem. But here's where people are going to get confused. There's an additional thing right here. What is this going to have us solve for? The 95% we're going to use to solve for the what? You bet, 6 p.m. tonight, your time. 6 p.m., Ryan. I'll see you there. Do some big 20 for first, 10 for second. So what is the 95% going to tell us? Was that your guess, Adam? Might be a pretty good guess. That's a really good guess if so. I think it's a pretty good guess. What is the 95% going to have us? Bingo. Charlie's right. That's the z-score. So this is going to get us the z-score. Now, this is where a lot of people get stuck, and you have to use the David M. Lane a lot of times. So you can memorize these. I've, taught this class a little bit, a decade. That's going to be funny when I'm like, 3 decades. I'm an old man. Haha. No more jokes, Brian. So you go right here to the value from an area, and you put in the percent confidence, and you go to between. It's very important here that these are z-scores, because the z-scores are the standard normal curve, and this is how we can get the z-score. It's on a 0-1 normal curve with a mean of 0 and a standard deviation of 1. And here is a 95% confidence rule. It's very important to use the between. And here's the value. You can get so if anyone's wondering, if it says 80, if it says 90, if it says 95, if it says 98, 99, any of these values can be obtained for a confidence rule. You must click this button. You must put the value here, have 0, 1, and do between. So this is how you obtain any sort of percent confidence level. And we will... Good question, Charlie, right there, 100 points. We will give you these on the test. We don't expect you to memorize these because you don't need to, so why do it? And so we would give you them on the test. And from here, we got the problem basically solved. We know that the z-score is equal to 1.96, and my pen is possessed because it keeps changing. And so right now, we just need to do the formula of p hat plus or minus the z-score. We put a star to say we picked it. P hat, q hat over n square root. And this has basically got it. We're just going to put in the values of 0.1516 plus or minus the z-score of 1.96 square root of 0.1516 times 8484 over 554, I think it was. And that should do it. I need help with the wording part. Yeah, let's do that next. Yeah, we'll do that. So how close was... They might have been really close. Let's see how close Adam's guess was. Adam, you might have been right on it. So there's that. So this times... there we go, 1.1516. That looks correct. Divided by 554 and square root. That's p hat times q hat over n square root. So you might, let's find out, 1.96. And it's basically 3%. So your answer's super close. I think you basically did you work it out? Because you're really close. If that was a guess, you might have done it. So 0.1516 minus the margin of error. Yeah, you're really close. And then, oh, great job. Did someone else ask it? Nice job, Charlie. Another 100 points. Mallory, 100 points. Thank you for asking. You both are on fire with the answers today. Sorry I missed that, Mallory. Mallory, you are, and Charlie is correct. There it is right there, 2.5758, or 56 rounded, or 2.576 rounded. So that is it right there on the screen, 99% confidence interval Z-score. Great questions. Good to have you here, Mallory. So here's the lower bound of it. Make sure to change it to a percent. 12.2, so it rounds. And then use the 0.1516. That is correct, right? Plus this, 18.1. Oof, it's close numbers. Should be correct. Everything should be correct. I think I carried enough decimals. Just make sure to carry your decimals and do the math very carefully. Then change it to a percent. Explain what it means right here. I am blank percent confident that the true proportion of blank is contained in the interval blank to blank. I can't state this enough right here. That is, I am blank percent confident that the true blank is contained in the interval blank to blank. So this right here is the 4 parts to a confidence interval. I am blank percent confident that the true blank is contained in the interval blank to blank. So we're trying to estimate the true proportion of teenagers that are in these drunk driving accidents. Such a happy topic. Don't drunk drive. Please don't do that. So, oh, it's uninsured. It's just accidents. So we are 95% confident that the true percentage of accidents involving teenagers is contained. Oof, they shouldn't put that falls inside. There are some questions where it says the true proportion randomly sampled. Yeah, it shouldn't be randomly sampled. It should be the true proportion, because we're not talking about the random sample right here. The random sample is. So this is the literal answer to the random sample. The random sample had 15.16%. So we know the answer to the random sample. The random sample, we observe 15.16%, but we think the true proportion of times that teenagers might be behind the wheel of an accident, for accidents that exist, the true proportion of accidents where teenagers behind the wheel is 15.16%. Because we know the sample proportion, we're trying to estimate the true proportion. So we know the answer for the sample. And then this doesn't give the interval, and then they should give the interval, and I should talk to Pearson about that. So this is a good theory one right here. 95% of 95% confidence would create an interval that contains the truth. So it's not that the sample proportion would be contained in there, it's that the true proportion might be contained in the interval. And it's that 95% of our random samples, which is 95% of the time when creating 95% confidence rolls right here. So 95% of random samples will produce 95% confidence rolls that contain the true proportion. That's what we would expect. A politician urging tighter restrictions on driver's licenses issued to teens says 1 in every 5 auto accidents has a teenager behind the wheel. Do you believe this claim or do you reject it? So with this right here, take a look at your interval. What percent is 1 in 5? What percent is 1 in 5? What percent is 1 in 5? So 1 in 5 is what percent? Oh, cool. See you, Adam. Good. Have some great lunch, man. What percent is 1 in 5? And I think GG has the next question, so we'll do GG's. And keep putting those questions up here. 1 in 5 is 20%. So do you believe that claim or reject that claim? This will go to what we'll be doing next in this class. But do you believe it or reject it? You say, that seems believable. Or you say, I reject that. We'd reject it because it's not in the interval. And that's going to come into play later in class. So the interval would contradict because the figure the politician quoted is outside the interval. Not today, my Pearson. Not today. 100. That's how we do. Not today. You're not going to trick me with some of those questions. Gigi's question was, let's look at Gigi's question right here. Could you work over part 2 of chapter 13 homework? Question 2? Let's take a look at what question 2 is on the homework. Question 2 on chapter 13. Is this the one due tonight or the one due, when's the next one due? It's due on Thursday night. Is this the one due tonight or Thursday night? Tonight or Thursday night? Because sadly, there's 2 chapter 13 assignments. I'm going to assume it's this one. This one's a fun one. Ooh, this one's fun. Let's see. Due Thursday. Cool. Yeah, this one's fun. Oh, this is a good one. Thank you, Gigi. Great question right here. This one's tricky one on the wording. I'm going to keep waiting for them to knock on the door and say, give us back that thing that's setting up your phone. A catalog sale company promises to deliver its orders placed on the internet within 3 days. Follow-up calls to a few randomly selected customers show that a 95% confidence interval for the proportion of all orders that arrive on time is 83% plus or minus a margin of error of 5%. What does this mean? So let's automatically do this. Who here can write out what this interval would mean using our interpretation? So take this right here. Remember, it's a catalog company saying what percent of the time the orders arrive on time. So take this interval right here and see if you can turn it into the real interval. I need someone to give this a shot. So remember, it was a 95% confidence interval. We're trying to figure out what percent of the orders arrive on time, and this will be the right interpretation. So we'll know the right interpretation. And if we know the right interpretation, it'll make our lives easier. So try and do this while I'm doing it. The more practice you get, the better. Can you figure out the interpretation? I am 95% confident that the true, let me put this way. What'd I do? True proportion of time the orders arrive on time is contained in the interval. And then we go to lower bound, 78% to the upper bound, 88%. I'm 95% confident the true portion of time the orders arrive on time. So will you please do number 3 on Thursdays? Homework after? Yeah, of course. The homework? Yeah, you got it. Thank you, Mallory. Good question right there. So between 78 88% of the orders arrive on time. What sounds wrong about this? Like, look at the correct interpretation we wrote. So we've got our right interpretation right here. We can put this on the screen right here. And I am 95% confident that the true proportion of times the orders arrive on time is contained in the interval blank to blank. So what is missing? Very easy to see with this right interpretation versus this bad one right here. What is seeing? What do you miss? What do you see instantaneously that is missed? Well, so we could change this to portions of, we could change this to of orders that it autocorrects now. Yeah, it doesn't have the confidence. So we would say that this one implies certainty. Can you help with explaining why we cannot model this relationship with a linear regression for... Yeah, we'll go back to that, Ryan. You got it. After we're going to do one more tool on this, then we'll go back and do that one. You got it. This one implies certainty. And so that's bad. Doesn't give the confidence. Let's look at this one right here. This one says 95% of all random samples of customers will show that 83% of orders arrive on time. What? Just what? You want to talk about a bad interpretation? No. That is just wrong. So think about this. You're saying if you take a random sample, 95% of the time you'll see 83%. That is a complete mixing up of everything we say. I think you're right. It's not that none of them will show. Could you get a random sample that has 83% in it? Could that theoretically happen? So what do you think? Because some of the samples could show that. So since it could occur, but you're not saying it will occur 95% of the time, it seems like the answer should be what? Because it's saying 95% of the time you'll see 83% in your sample. No. Yeah, it's A. Nice job, Gigi. Excellent work. It is A. Because much less than that would show up. Much less than that. 95% of all random samples of customers will show. This one sounds confident again. So let's see here. Because the interval, that's not the interval. So this one's just flat out wrong. That's not the interval. There's the interval. So it's got the right interval. The confidence level must be equal to the margin of error. Nope. It's going to be this one. The estimate. Yeah. So 95% of all random samples will show that 78. Yeah. So this sounds similar to ours, but it's talking about the random samples here instead of the true proportion. So 95% of the time, or we're 95% confident that the true proportion. So it's talking about the sample in theirs. Theirs talks about the sample, where ours talks about the truth. We're trying to figure out what is the truth for the percent of orders that'll arrive on time. So it should be this one. That's the weirdest one we've seen so far. I don't like that one. Oh, this one looks better. Looks better. Let's see if it's right. One is 95% sure. I am 95% confident that between 78 to 88% of the orders placed by the... What if they wanted to change this? What could we change by the sample customers to make it sound very close to ours? So instead of saying by the sample customers, it should be by what customers arrive on time. We could almost make this one work. Instead of saying one can be 95% sure that between 78 to 88% of the orders placed by the sample customers arrived on time, just change sampled to something else, and it would actually be pretty accurate. Because we're not trying to make a confidence interval to estimate what happens in the sample. We're trying to make a confidence interval to estimate what happens for what. The confidence interval takes from a sample and tries to figure out the truth for a what. Sample is this, and then you're figuring out the truth for this. And just think about elections. When you do a poll, you take a sample to figure out what will be the truth on election day, which is that P word right there. It'd be the what. We're trying not to figure out for the sample. We're trying to figure out for the... I know someone knows it in the chat. It'd be the population. The population. So all customers. So this could have been right if it said of the orders placed by all customers or the population of customers that we have. Because we're going to sample our customers and be like, okay, are we meeting our goals? And then we won't know for all customers, but we can make an estimate of what the truth is for all customers. So this is not correct. We do know the answer to the sample because we know 83% from the sample got the order on time. How do we know that? Because this right here that's P hat. The center of the interval, and we were seeing this just a moment ago, the center of the interval is P hat, and P hat is the sample proportion. So we know 83% of the sample customers got their order on time. So we know the proportion of the sample that got their orders on time. There is 95% chance that on a given day, what are we talking about a given day for? There's a 95% chance that on a given day, a customer has a 78 to 88% chance. The whole given day is not what we're talking about. We're talking about I am 95% confident that the true proportion of orders that arrive on time for any day. So we're not talking about a given day right here. So let's see. Yeah, I think right here, first the probability of the interval containing the population parameter, the confidence interval is an estimate of the sample. No. So it should be this one. Double checking. 95, the confidence level 9 refers to the probability of the interval containing the population parameter. It should be right. That one, it just seemed closer, and I'm like, are they saying that's correct? It doesn't look correct. This one right here is a little bit tricky, but it's because of the small numbers. So this problem right here is a little tougher because of small numbers, but let's make it work. Let's identify our notation right here. Can we go over the visualization tonight? Yeah. I'm going to put out a video tonight. We can definitely talk over it some here, and I'll put out a video. We're going to do a 320 question right after this. Though we can do visualization, you got it. Should have a video out for it tonight. Tonight. So this question right here, what do we see notation-wise? Does anyone see any notation on this question right now? We should immediately identify notation on this question and be like, okay, that is notation. A philanthropic organization sent mail, labels, and greeting cards to a random sample of 100,000 customers, potential donors on their mailing list, and received back 4,507 donations. So what is a notation right here? And then we want to make a 99% confidence roll. Any suggestions on notation? Does anyone know any notation? A single bit of notation. My kingdom for notation. Notation. Nice job, Gigi, right there. You're right. That's N, which is the sample size. We'll go over here. This is X. Oh, no, you got it. You're right. No, you're 100% right. That's totally right. And this is the Z-score related. That's not the Z-score, but that's how we're going to find the Z-score. So once again, if you're thinking about how do I get that Z-score, you need to go to the David M. Lane or memorize them. Nothing wrong with memorizing them. But here you go. Here's this. And there's the David M. Lane in the chat. And here's how you get the Z-score. You need to click on this second button right here. Very important you click there. You have 0, 1 for the mean and standard deviation, which is the normal curve, the standard normal. And then you put in the percent confidence. And all of these are now Z-scores. There's also Z-scores tables, and they're not as fun as this. This just gets you answer like that. And you can see it and you can visualize it. You can see 99% of the curve is shaded in. So this is our Z-score, 2.5758. The extra decimals right there that we can't see. So that's 2.5758 obtained from the David M. Lane applet. From here, it's just solving the interval. From here, it's just little decimals, and just carry them in your calculator. Make sure to carry all of them. But we need to find p hat. Does anyone know the equation for p hat? I'll solve q hat for you. Q hat is 1 minus p hat. P hat is going to be equal to 0.04507. What is the equation for p hat? P hat is x over n. So x over n equals p hat, which is just the amount of successes over the number of trials. So you're saying, what percent of the time did we observe this in the sample? So it's going to be 4507 over, there we go, right there. So that's going to be the sample proportion right there. So the sample proportion of observations is 4.507%. Now q hat is just the complement. So when you think about this, you're just going to take p hat right here of 0.04507, and you're going to do 1 minus and get q hat. So q hat and p hat add up to 1. This is kind of key right here to know that they add up to 1. So 0.95493, I think it is. Is that right? Just saw it for a second. 95493. What is the best? Oh, when is, I don't know. Should we premiere it tonight? We should premiere it at like 10 p.m. or something. I need to finish it up tonight. I should try to premiere at like 10 p.m. Join in for the premiere. Yay! And I haven't done enough premieres lately. Man, this semester's been, and we have the visualization Friday, so I think a good bit of time. Get it out today. It's not that bad a one, but I still want to make all the help videos and everything, make sure people are understanding the material. And so we should have that. And from here, we saw him. It's good to see you here, Dan. Let's see. So now we need to write the p hat plus or minus, and then p hat times q hat over n square root. P hat times q hat over n square root. So 0.04507 plus or minus 2.5758. Almost forgot my z-score for a moment. And square root 0.04507 times, it's going to block it right there. 5493 over 100,000. Okay, let's take a look. So we have this number right here. We're going to times it by p hat. There's p hat times q hat, square root. Then we're going to times it by 2.5758. And I've just found the what. This right here, by timesing all of these numbers together, is the what of this interval. I just timesed all of this together. So what did I find by timesing all of that together? What is all of that right there? Everything times together, 0.00169. 0.00169. Oh, it's the margin of error. That'll be the margin of error. So every time you see a plus or minus, great job right there, Dan. Every time you see a plus or minus, that's going to be the margin of error. When you think about an interval basically goes up a certain amount, an interval goes down a certain amount, and this certain amount it goes up and down is the margin of error. So it goes up a margin of error, and it goes down a margin of error. So the interval goes plus or minus. During routine, a doctor notices that 20% of adults' payments show high. Yeah, which one is that, Charlie? Is that on the quiz? And so we should have this one correct. I did square root it, right? I think it is a pretty small number. So let's go back. 99% confidence. Yeah, I guess with that big of a sample, it will be pretty small. Okay, so we take this, 0.5 plus this, so 4.68. And then minus this, 4.38. Wait, 4.34. I think I did it right. Woo! Scaring me right there. Scaring me. Do I think 4.6 is plausible? Well, of course. It's in the interval. So I'm saying I'm 95% confident the true proportion of people who respond to this mailer is contained in the interval 4.34 to 4.68. Once again, I am 95% confident that the true proportion of people who will respond to this mailer is contained in the interval 4.34 to 4.68. If you're wondering what I'm doing, I'm using the interpretation we have written right here. and using the basic format of it, where we say I am blank % confident that the true blank is contained in the interval blank to blank. I am 95% confident that the true proportion of people who will respond to this mailer is contained in the interval, and then the numbers we gave right here. So understanding this right here, the 4 parts to a confidence interval, is very important, and then I'm able to interpret it. So I think 4.6 is reasonable because it's in the interval. And that's got that one. Let's see right here. Oh, wait, there was another one, right? Could you go over the visualization? Wait, someone wanted a 321. 321. Can you explain why we cannot model this relationship with linear regression for 321A? 321A. What is 321A? 321A. There's random hairs every day. That's the joys of long hair. The longest hair. And so does this one say, why can't we model it? Oh, I think I know why. Yeah. Okay. So are we predicting, I think we're predicting the meat weight from diameter, right? I think this model, correct me if I'm wrong, 320 if you're here. Well, thank you, Ryan. I appreciate that. We're just having some fun right here. So I think this wants us to make the plot. I hate making the plot of it. We're just having fun. So this is these are abalones, which are apparently are very expensive fish. And so there's the abalone data set. So there's the abalone data set. And then what we're going to do is we're going to use the variables. We're going to predict the meat weight and diameter. Cool. Let's do this. Meat.weight diameter. And then we need to do data equals, and then ex3 abalone. So figure's too large, of course. And there we go. Now what we have to do if we want to plot the line through it is we have to make a linear model. So probably, let's make that first. To make the linear model, we're just going to make some adjustments. And please note what I did right here. All I did to make those adjustments is I changed the function I'm using, and I stored it into M. And then we can do this. We can go to AB line and add M to it. I'll show this code. Let me zoom out a little bit. There's the code in full. And you could go to col equals red. And there is the linear model. Let's show it. Do you see any issues with the linear model? There's 2 major issues. And then we'll do Charlie's next right here. Because I wanted to get done earlier today, but I have no idea. Oh yeah, and then we'll do Annette's question too. Well, so the key word is here. Why do you think linear regression has an issue? Why do you think linear regression has an issue? So there are outliers, and so I do see outliers, but I also see more. Yeah, the linearity has a big issue. If you notice here, it has this big bend to it. And this is probably best seen if we'll be seeing these advanced features late in a little bit. But if we do choose order, you can really see the non-linearity to this model. So here's the view of the choose order, which definitely shows that there is a non-linear relationship, probably a polynomial bend to this model. So you can see the line is the black line through there. And if we were to fit a non-linear model, it would do much better. So we do have options for this kind of stuff, but linear regression does not seem appropriate because one of the key assumptions is QQ straight enough, no outliers to throw back some 201. And you notice that the line does not properly go through the data. So this does not seem reasonable. It would be a model that does not well reflect reality. We want our models to look like what the data looks like. And this is kind of pushing a model onto it that wouldn't. No, don't worry. Sometimes you see it and you're like, oh, linear regression. We want it to the line to fit the data well. And then you're like, I got it. So that's what it's all about. Let me pull up the visualization. Annette, thank you so much for being here and asking the question. Let's go look at the visualization. So they came an hour ago. They knocked on the door. And I was like, oh, they're going to knock again when... I hope it's not happening when I teach. Oh, and I got a meeting at 1 today, so I need to go to that. We'll figure out what's going on. It is a crazy world we live in. I didn't know it's so hard to set up a phone. You know, it's so weird. You think a phone, you just plug it into the wall. You say, hey, I want phone service. I just had pareidolia. I saw a face and I was like, someone comes in here. At least I'm streaming on the internet if anything crazy happens. It's like one of those horror movies. Okay, so let me pull up the data here. I'm gonna go to space real quick. Space. Okay. We are getting the data pulled up, getting the assignment ready. Take a random sample, 100 plus the 2 digits of your UTID, create a 92.3% confidence interval. For whether or not people smoked marijuana, using yes as the desired response. Take a screenshot of the bar chart, frequency tables, confidence interval into your Word document. Include a short write-up of the confidence interval. Make sure you include the 4 points of every confidence interval. Yep, 4 things. Note the population of interest here is Stat 1 students. Primary interest is the proportion of Stat 1 students who have smoked marijuana. Okay, we got this. We can wreck this interval. Let's do this. So we have the data now open. Let's hop back here to the main screen on these 20-point Tuesdays. Let's do this. Yeah, so many points. Love it. Okay. So for this one right here, we're going to take a random sample. So we just go here to tables. I could have to do the video from this. I could have cut this part of this. Be like, hey, everybody. So today we're going to take a random sample and make a confidence interval from it for a categorical variable. I'll make it later tonight. So let's go here to tables. Let's go to subset. We've done this a bunch of times. And we go to table and subset. We're just going to do the 100. And the coolest thing is you can just hit enter there. It's pretty quick and easy. I know I could do it right now. I want to make a full-fledged video. I know. I like doing because then you'd be surprised how many edits there are in those videos. Sometimes when I do a zoom in, I actually cut the video, or I cut what I say because I'll make a mistake or I'll say something in a way I don't like. So there's a lot of cuts in those videos to make sure, and then I don't make any jokes or anything. I'm like, hey, this is how we do it. And I'm super serious. And I talk through, like, it's not as chill as this. It's serious. It's a serious face right there. So, okay, so we took our random sample, and this is, everyone will have a unique random sample to them. Yeah, let's do the environmental agency. You bet. And so we're going to now go to analyze, and we're going to go to distribution. Under analyze distribution, this is how you analyze univariate categorical data. Now, I'm not going to do your variable, so I'm going to do a little bit different of a variable. Let's figure out the proportion of people born in Tennessee. So I'm just double-clicking the variable and putting it right there. Now I'm going to click this and click stack. It just makes it look nicer. Then we're going to click the second red arrow here, and we're going to go to confidence interval and go to other. So when we go to other, we can enter in the percent confidence, like 98.8. Maybe put in the one it tells you to put in. But put in the percent level of confidence it wants you to put in. And this gives you the percent confidence interval that you asked for. And from here, we're basically done. So from here, in the video especially, I'll be showing this right here. And I think I can make it the small window again. So once we've done this, we're pretty good to go. This is the output you need. And I don't know if there's a way to make it sound like Tina. I did it. No, I've done it before, and it sounds way better. Bob's Burgers. But does this make sense right here, Annette? This is the output you need, and hopefully this helps in the video. And from here, we can interpret this interval, and this creates the whatever percent confidence interval we want. Don't make a 98.8. Don't use born in Tennessee. Use the variables it suggests you use. And then you're doing a categorical variable here, which is a confidence interval for the true proportion. So this is the true proportion of people born in Tennessee. So I am 98.8% confident the true proportion of people who are born in Tennessee who go to University of Tennessee is contained in the interval 44.5% to 68.6%. I am 98.8% confident the true proportion of people who are born in Tennessee who go to the University of Tennessee is contained in the interval 44.5% to 68.6%. And there's the lower bound and the upper bound. Hopefully, does this make sense right here? I think we have another 201 question. The environmental agency is trying to clean up air for emission standards. Is that Thursday's assignment, Gigi? I think it's Thursdays, right? Is this the homework for Thursday? Is it homework? I'm breaking the assignment. This is the sales. It's a quiz question. Cool. Let me do the quiz then. It's a quiz question. Oh, and then, I think Charlie's was first. So we'll do Charlie's. We should have enough time for both. Yeah, I got more enough time. So we'll do Charlie's because I think his was first. And thank you, everybody. Everyone is so awesome in here. Like, everyone's very positive. People jump in with their questions, like, in a good way. Like, everyone's like, hey, can you do this question? And then we all just hop in line what helps me with this is actually I used to wait tables, and when you wait tables, I would have this running list in my mind. I'd be like, okay, I'm gonna fill up the water pitchers, then I'm gonna check to see how table 34 likes their food. It's so funny. I can tell you where table 34 is at Cheddar's. It's gonna be outside the atrium area. Cheddar's and Kingsport. They probably renumbered their tables like that go there. Both of the questions I think you solve the same. Yeah, they're probably pretty similar. Let's do that. So yeah, Charlie should. So during a routine doctor screening, during a what, the same question looks like. During a routine doctor screening, there's the environmental. Okay, here we go. During a routine doctor screening, a doctor notices that 20% of her adult patients show higher than normal levels of glucose in their blood, a possible warning sign for diabetes. Diabetes. Hearing this, I think Wilford Brimley just died. Sad times for Wilford Brimley right here. Hearing this, some medical researchers decide to conduct a large-scale study, hoping to estimate the proportion to within 6% with 99% confidence. How many randomly selected adults must they test? Okay, so we do have some notation stuff right here, and it gets pretty tricky. This is a tougher question because it's an algebra question. No one likes the algebra questions. So can you identify any of the notation? I'm going to need some help here with the notation. So can you identify any of the notation in this question? This is kind of the key to all questions. So hoping to estimate the proportion to within 6% with 99%, and they notice 20% at first. So they notice 20% at first. So they want to talk about, I think it says what sample size do they need? So they're solving for n. I think you're right. Charlie's totally on the right track right here. Nice job, Charlie. Charlie identifies that the margin of error is 6%. The p hat that they're using is going to be this. That means q hat is the complement of it. Remember, p hat and q hat add to 1. If p hat is 0.2, q hat is 0.8. And then the z-score right here is going to be relative to a 99% confidence interval, which is 2.5758. Just a reminder, like if you're watching this part of the video late, like you haven't watched the beginning, which is all right. I put the timestamps in here for a reason. We have the David M. Lane applet, and that's how we're getting the z-score for a 99% confidence interval. Once again, notice how I have the screen set up here, where we have the z-scores, the 0-1 curve. This is clicked right here, and you can now find any sort of z-score for any percent confidence interval. If you want 95, 98, 99, here's the relative z-score, and you do the plus or minus, so it doesn't matter which one you pick. So there's the z-score we got from the David M. Lane applet, and I think we've identified everything. Now, what we need to do is we need to solve part of this interval. The part of the interval, not that. The part of the interval we need to solve is going to be the margin of error. So the z-score times p hat over n square root, we're interested in this. This is the margin of error. That's the margin of error. So what we need to do here is we need to set this portion. Nice job, Charlie. You're awesome. We're going to set this portion right here equal to 0.06. So we're setting that equal to 0.06. And then we are going to take and do 2.5758 square root, and then do the p hat and q hat 0.2. Luckily, they're small. 0.8. And then we're going to do over this. And then we're going to do the n is what we're going to solve for. So this is everything right here. We now have 0.2, we have 0.8, and 2.5758. So we have all the information we need, every bit of information. And so what do we need to do? We need to solve algebra. Not fun. One thing we could do, is a huge help right here, is we could take and we could back reverse this for n. So to get n from this, we can take, I'm just going to take this right here. So here's a really good helper. Oh, 2 seconds. He's here. Be right back. Right back, everyone. Hey everybody, I am back. Sorry about that. Had to give back the telephone thing so our telephone service is set up. And so we have the margin of error right here is equal to this equation. So what I'm going to do is I'm going to take and divide the margin of error by the z-score. And that makes this equal to this right here. Does that make sense to everybody? We're just doing that. Then I'm going to square both sides. So now that I've squared both sides, I get rid of the square root. And now I think we're almost there. We just need to flip and then multiply. So you can flip both sides. We should be able to flip them. So if we flip both sides, one of my favorite tricks is you can just flip equations. You can just take and flip z over me squared is equal to n over p times q squared, all that, and it's no longer square root. And then we're just going to multiply both sides by p times q, because when you multiply by p times q over here and p hat times q hat, over here, these two will multiply. And guess what we just solved for? There we go. That is the solve for it. And now we just need to put in the numbers. And this might be an easier way to work with, but we just plug in our numbers. If we identify the notation, this should solve out accurately. So the z-score was 2.5758. We divide that by the margin of error of this. We square this value, and then we multiply this by 0.2. And we oh my gosh, where do my numbers go? The z-score was 2.5758. We divide that by 0.06. Then we square this. We're going to copy this number, multiply it by 0.2, multiply this number by 0.8. So the answer is 295. Is this one of those round up problems? Does it say round up? Round up. And so the answer is 295. Rounded up. Did we do it correctly? Yes, we got it. So that's a little bit of a tricky one. If you notice the mathematics we did, we basically wrote it out so we could just plug in the numbers here. And we algebraed out this so that we can find the sample size. So hopefully that makes sense. And then we can do the cars one right here, which is the previous one. We got more than enough time. So with the cars one, I think it's very similar, right? The agency first picks out 60 cars and finds that 9 of them have faulty emissions. They want a margin of error of this. So we can use the same theory on this. So let's grab the information right here and let's use the information. Does anyone notice any sort of, hey, have a great day, Dan. So good to have you here. Sorry I had to run off for a half second there. Someone's like, Brian left for 10 seconds. Well, I missed probably 2-3 minutes. I'm sorry. So does anyone see any of the, I'm deleting our old notation. Does anyone see any of the notation in this problem? So if we can identify the notation here in this problem, will be good also. The notation we need is going to be this, which is n, this, which is x, this, which is going to be the margin of error. This right here tells us the z-score, which is 1.96. So we can now get p hat right here, which should be 15%. So 9 over 60, which is x over n, is equal to p hat, which is equal to 15%. That makes q hat, which is 1 minus p, equal to 85%. So these two add up to 1. Just remember that p hat and q hat add up to 1. So now we just solve the equation. The 1.96, just to repeat, was found via the David M. Lane applet. I'll drop that in the chat here again. So when we want to get a 95% confidence interval, we can go to the applet, which I have in the chat right there, and find any of the confidence interval z-scores needed. If you notice, as you go to a bigger confidence, you have a higher z-score. Bigger confidence, bigger z-score. So just understanding here that a 95% confidence interval is basically 2, because 68, 95. Let's see it again. You ready? 68, 95, 99.7. If you're wondering why it's not quite exact, it's because there's more decimals we don't tell you. So 95 is 1.96, and we just plug in our numbers right here. So let's see if we can remember them as we do this. They're going to be a little small, but we're going to take right here, we're going to take the z-score of 1.96. So 1.96, we're going to divide that by the margin of error, which is 0.04. We're going to square this, which is 7 cubed, isn't it? Or to the 4th power, I think. Sorry. Holding my pen and everything. Okay, crazy day. And so that is the inner part of this. That's z over me squared. And now we just need to times it by these two numbers. So times 0.15 times 0.85. And now we've solved for the sample size. So if it says round up, it'll be 307. 307. Round up. 307. We've done it. Does that make sense, GG, and everyone asking? These are my shoulder. How is everyone doing on those numbers right there? These are some of the more difficult algebra questions, but once you have this equation right here written out, and you can identify the notation. So the 2 steps to this is have this equation. Nice job, GG. Great job. So if you have this equation right here, which is a reworking of the margin of error, because you solve for the margin of error, and then you just rework it so you can solve for n. And once you do this, you can just plug and chug the numbers. I don't like these types of test questions. They're my least favorite. But the good parts of these questions are the identify notation. Oh, no, Charlie, no. No. I need to make an online applet for this, which I could make. You got it, Charlie. You got it. You thought you were in stats. I know, right? It's a notation question. Consider it a notation question. The algebra is secondhand. You got it, Charlie. You can make 100. I know you can. You got this. It's just, yeah, carry those numbers very carefully. Be very careful. Are there additional questions? I have a meeting at 1, so I'm going to hop to that. So many meetings. I had a meeting after 201 yesterday. I had a 201 meeting this morning. We're going to have a 320 Kahoot tonight, prizes. So for the 320 Kahoot, feel free to join in 201, but it's going to be a tough Kahoot. I need to go on. I need to make a 20-question Kahoot. So I've got some questions ready to go and put some of the questions from the test on there. So I think we'll probably head off here in a moment, but really good. Could you go quickly over several factors are involved in the creation of a constant roll from the quiz? Oh, so is this the... Yeah, let's take a look. Yeah, no worries. No worries, GG. We're going to run out of time, but we're going to try to squeeze it in here. Let's try. So several... Is this from the Canvas content quiz? I'm assuming it's Canvas content quiz. Let me go over here. 2 seconds. Canvas content quiz. Let me take a look. What does it say? This one is due on the... Is it the Canvas content? Oh, the Pearson quiz. What does the question say? Several factors. Oh, cool. Yeah, I got this. Let's crush this one. You ready? We got this. Thank you, Amber, so much. Have a great day. So good seeing everyone here. So several factors are involved in the creation of a constant roll. Among them, there are the sample size, the confidence level, and the margin of error. Which statements are true? For a given sample size, higher confidence means a smaller margin of error. So if you increase the confidence, you increase the what? If you increase the confidence, you increase what part of the interval? If you increase the confidence, I need everyone's help here. We got to get this done in 2 minutes. If you increase the confidence, what will increase about this interval right here? If you increase the confidence, what will increase about this interval? If you increase the confidence, what will increase? Increasing the confidence will directly increase this part of it. What part? We could literally have seconds. We got to figure this out. Close. The Z. The Z is related to the confidence. So the Z is what we get from the David M. Lane, and that's related to the confidence. So if you increase the confidence, then you're actually... So higher confidence means a smaller margin of error. If you increase the confidence, you'll increase the margin of error. So this is very false. For a specific confidence interval, larger samples provide smaller... for a specified confidence level, larger samples provide smaller margins of error. So if you notice where this is at, if you have a specified confidence level, then you're going to increase n. Increasing n right here would make the interval smaller. So that's very true. So if you increase the sample size, the margin of error will get smaller. There's a tricky one here. For a fixed margin of error, larger samples provide greater confidence. Yes, this is a tricky one. Because if you fix the margin of error, then you're going to have a balancing effects. What you're saying is, and this one has caught me before. So if you fix the margin of error, this is going to equal up to the same number no matter what. And it says for a fixed margin of error, larger samples provide greater confidence. So if you were to increase the sample size here, it's literally time. So if you increase the sample size right here, larger samples, yeah, then you could increase, because this will get bigger, and then this could also get bigger right here, because this, by getting bigger, makes it smaller. If n gets bigger, it gets smaller. If z gets bigger, it gets bigger. So they kind of counterweight each other. And literally, I have seconds here to go. So this is true. For a given console, having the margin error requires twice sample size. That's false. It requires quadruple, 4 times, 100%. Let's go. That's it. It requires 4 times, which we did a problem like that yesterday during office hours. Check out yesterday's office hours where we solved the one where you have to quadruple the sample size. That's it. I'll see everyone soon. Bye, everybody. Bye. You're welcome, GG. You're great.